Are we alone in the universe? This age-old question has baffled humanity for centuries. Welcome to the fascinating realm of cosmic wonder, where we have been pondering this profound question. Our universe, a vast expanse of cosmic wilderness, is teeming with galaxies, each one a bustling metropolis of stars. There are more stars in the universe than grains of sand on all the beaches on Earth. Imagine the staggering enormity of it all. Now, consider this. Each of those stars could potentially host a family of planets. And on those planets, under the right conditions, life as we know it, or even as we don't, could possibly exist. The potential for extraterrestrial life is mind-boggling, yet we have no definitive proof of its existence. The universe is a grand cosmic lottery, with innumerable tickets drawn every second. With such a vast cosmos, the odds seem in favor of life elsewhere. But where is everybody? Astronomer Frank Drake devised an equation to estimate the number of advanced civilizations in our galaxy. So what is this Drake equation? Well, it's a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It's not a strict mathematical formula, but more of a way to stimulate intellectual curiosity about the universe around us. The Drake equation considers several factors. It starts with the rate of star formation in our galaxy. Then it takes into account the fraction of those stars that have planetary systems. Next, it considers the number of planets per solar system with an environment suitable for life. But the equation doesn't stop there. It delves deeper, considering the fraction of suitable planets where life actually develops. It asks, of those, how many develop intelligent life? And of those intelligent life forms, how many develop technology that releases detectable signs of their existence into space, such as radio signals? However, the Drake equation is not without its fair share of controversy. It's a fascinating tool, yes, but it's also filled with assumptions. Each factor in the equation is fraught with uncertainty. For instance, we're not exactly sure how common life-sustaining planets are. We're also uncertain about the likelihood of life developing on these planets, let alone intelligent life. And even if intelligent life does develop, would it necessarily create technology that produces detectable signals? So while the Drake equation helps us ponder the existence of extraterrestrial civilizations, it's far from conclusive. It's more about asking the right questions than providing concrete answers. The vastness of the universe, the myriad of possibilities, the sheer potential for life out there, it's all encapsulated in this one equation. But remember, it's an equation built on a foundation of assumptions and uncertainties. So, the Drake equation gives us a way to make educated guesses, but it doesn't provide definitive answers. Physicist Enrico Fermi posed a powerful contradiction, now known as the Fermi Paradox. This paradox, named after the Italian physicist, presents a captivating puzzle about our place in the universe. Let's dive into it. The paradox is actually a question. Where is everybody? It's a question that arises when we consider the sheer size and age of the universe. There are billions of stars in our galaxy, many of them older than our sun, and many of those stars have planets. Given the vast number of planets, some of them should have developed intelligent life, perhaps even civilizations more advanced than our own. Yet, despite the high probability of such civilizations existing, we have no concrete evidence of them. We've never received an alien transmission or found an extraterrestrial artifact. This discrepancy between the high likelihood of extraterrestrial life and the lack of evidence or contact forms the core of the Fermi Paradox. Now, some might argue that space is vast, and we've only just begun to explore it. But consider this. If a civilization developed interstellar travel, even at a slow pace, they could theoretically colonize the galaxy in a few million years. In cosmic terms, that's a blink of an eye. So, if there have been civilizations capable of interstellar travel, why haven't they reached us? Why is the cosmos so silent? Perhaps we're not listening correctly, or maybe they're avoiding us. Or it could be that life as we know it is incredibly rare or short-lived on a cosmic scale. These are just a few of the many proposed solutions to the Fermi Paradox, each as intriguing and perplexing as the next. In essence, the Fermi Paradox is a mirror held up to humanity, reflecting our hopes and fears about our place in the cosmos. It's a reminder of our profound isolation in the vast expanse of space and our burning desire to find others out there. The Fermi Paradox leaves us wondering, if there's a high likelihood of galactic civilizations, why haven't we heard from them? There are many theories that attempt to answer the paradox. First, let's consider the Great Filter Theory. The idea here is that every civilization has to pass through a filter, a critical point or phase that's extremely difficult to survive. It could be anything from a self-destructive war to a natural catastrophe. If we've already passed the Great Filter, we might be among the lucky few in the cosmos. But if the Great Filter lies ahead, our future might be more precarious than we'd like to think. Next is the zoo hypothesis. Imagine if we're not alone, but we're like animals in a cosmic zoo, being watched and studied by advanced civilizations. They might be following a prime directive of sorts, not to interfere with our development. It's a thought that makes you look up at the night sky a little differently, doesn't it? Lastly, let's talk about the transcension hypothesis. This theory suggests that once civilizations reach a certain level of technological advancement, they transcend, moving into a space that's unobservable to us. Like a caterpillar metamorphosing into a butterfly, they might simply be beyond our comprehension. These theories are fascinating, but like the Drake equation and FMY Paradox, they leave us with more questions than answers. Despite the uncertainty and the unanswered questions, the search for extraterrestrial intelligence continues. Tireless efforts persist, like the SETI project, which scans the cosmos for signals of other civilizations. Ambitious space missions are launched, peering into the cosmic depths, seeking worlds that may harbor life. Our curiosity fuels this relentless pursuit, this cosmic quest that transcends our earthly confines. So, are we alone in the universe? The truth is, we simply don't know, but the quest for answers, that's what truly makes us human.